Morning. Today we're going to be looking at a new sort of type of two-dimensional geometry, and in sort of where geometry and the measurement unit sort of blend or come across each other. And that is looking at perimeter. Now, I'm not sure if you guys have learned about perimeter at all in school yet. I think you probably have. I'm not sure you called it perimeter, but you might have done this last year in grade 3. So let's take a look at what perimeter actually is. So if we break perimeter down, the word itself, this is what it means. So it's a measurement of the line which forms the outermost boundary of a shape. So that sounds pretty complicated, but if you break it down, peri is a prefix that means outside, and meter, as you recognize meter, is a prefix that, or a root word that means measure. So perimeter means to measure the outside, and that's basically what perimeter is. You're measuring the outside, outermost line of a shape. So let's take a little problem and see how we can apply perimeter to a real world problem. So John and Mark, I'm just going to move their little picture over. John and Mark are setting up a cross-country track course for their school. The track is rectangular in shape and must fit on a field which is 100 meters by 100 meters. The track must be 240 meters long. What possible dimensions could I shouldn't say two tracks, could the track have? So basically, it has to fit on this field and it has to be 240 meters long. So what do we know about this situation? So we know. So this is what we know. We know, first of all, that the track must be, I'm just going to make some bullets here. Track must be 240 meters. What else do we know? We know it must fit on a field that is 100 by 100 meters. That means it's a square and the length is 100 and the width is 100, right? When by dimensions means length and width. That's what dimensions means. The other thing we know, if you put these two pieces of information together, what is the maximum side length of the track? Well, if it fits on a field that's 100 by 100, then the track can't really have a side length that's bigger than 100 unless it goes diagonally. But let's just say that all sides of the track must be less than 100 meters. So in other words, I can't have a track with the side of 110 and 110, right? The other thing we know is that, remember from the other day when we did definitions of shapes, we look at what a rectangle is. A rectangle is, so the track is four sides, and then opposite sides are of equal length, right? So that's the other thing we know, is that there's got to be two sides that are the same length and two sides that are the same length. They're opposite. They're let me just get another one of these pages here. They are the opposing sides have got to be the equal length. So I just drew this little, and you like my little running guys here. So I just drew this so that we could get an idea of what it might look like. I'm going to get rid of that. I'm going to put this up here because those are sort of my notes to keep track. So how do I tackle a problem like this? Well, if I was going to tackle a problem like this, the first thing I'm going to think about is, well, I've got four numbers, four numbers here, and they have to add up to 240. So I have box, 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 and I have plus, 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 equals. So these have to add up to 240 meters. That's what I know. The other thing I know is if I do length and width of my box, that these two, let me just ungroup this. These two boxes, this one and this one, must be the same number, and this one and this one must be the same number. That's because that would then assume that, let's say, this one is this line, this one is this line, they're the same, this one is this line, and this one equals this line, right? They're the same. So, because they're opposites and they're parallel, which means parallel meaning that the sides are equal. So I need to come up with 4 values that add up to 240. But the 2 values here have to be the same, and the 2 values here have to be the same. So how do you tackle a problem like this? This is sort of a guess and test problem, but it's also a bit of a decomposition problem. I'm going to look at the 240 and go, well, what friendly numbers are in here that I know I can break this into 4 numbers, and 2 of them have to be the same, and these 2 have to be the same. So I'm just going to pull out a number that's easy. I'm going to use the number 50. So I'm going to say my small side here is 50, and my other side here is 50. Now, I know that 50 plus 50 equals 100, which means that if I've got a value of 240 that I have to get to, I can easily then go, okay, well, if I've used up 100, then I can just subtract 100 from 240, and that's going to give me what I have left over, right? So these 2 boxes have got to be whatever I have left over here. 100 from 240, that's a pretty easy subtraction, right? It's going to be, I'm just subtracting 100, so it's going to be 140. I know that it's 140 that I have left, and I've got 2 values that have to be the same that add up to 140. Well, if I have 2 of the same number that add up to one number, like for example, say I said I have 2 numbers that are the same, they add up to 8. Well, what are you going to do? You're going to divide that 8 in half and go 4 plus 4 equals 8. Well, in this case, I'm just going to divide 140 in half. And I know that half of 14 from my math facts is 7. And then I'm going to throw that 0 on the end. So this number is going to end up being 70. And I'm going to clone that, 70. All right, so now I have my 4 side lengths. I'm going to double check my math. And the way I'm going to double check my math is I'm just going to add these up in my little trusty side edit here. And for some reason, this always defaults to double spacing, which drives me a bit nuts, but what can you do? Just fixing this. Spacing, I don't want that. There we go, that looks better. And now I'm going to just add these up. And put a little line under them so it looks a little better. And so 0 plus 0 plus 0 plus 0 is 0. And then I'm just going to add these up. 7 plus, actually, I'm going to do the 5s first because that's easier. 5 plus 5 is 10. 10 plus another 7 is 17. 17 plus 7, well, I know that 7 is 3 plus 4. 3 plus 17 is 20, so that's going to be 24. 240 checks out. I have my answer. Now, there's a lot of different ways I could have done this, right? I could have used different numbers in here. I could have put 60, 60, 60. Well, that wouldn't have really worked. But I could have, for example, made these 100 because the maximum I can have is 100, but I can use 100, which would have made this 200, which means they would have been each 20. It would have been a very weird looking track, but it would have worked. So there's definitely lots of possibilities here that I could have used. But basically, what you can notice is that to figure out perimeter of this, all I really had to do was multiply one side by 2 and the second side by 2 and add those answers up. So if I was to, excuse me, for example, say give you a track and said 50, 50, 70, 70, what is my perimeter? It would have been easy for you to go, well, 50 times 2 is 100, 70 times 2 is 140, 140 plus 100 is 240, which is basically what I did here, right? So that's sort of looking at how to figure out perimeter. So for homework for today, or it's not really much in the way of homework, it's just a sort of an activity to get you used to perimeter and what it means. I'm going to ask you to do two things. The first thing I want you to do is I want you to think. You don't have to write anything down. I just want you to think about how perimeter is used. So perimeter is often used in doing renovations or remodeling of a home. Why do you think someone needs to measure the perimeter of a room? Okay, why do you think someone would need, I'm going to, yeah, this is poorly worded here, would need to measure the perimeter of the room? If you're not sure, ask your parents, because I'm sure they've done it before for specific reasons, if they've ever renovated their house. So and then the second thing, and this is going to be tricky potentially, but I want you to see if you can measure the perimeter of your bedroom. Now, hopefully you have a rectangular or a square bedroom. If your bedroom is odd shaped, like an L shape or something, that might be really tricky, but it shouldn't be, because you're just measuring the outside wall of your bedroom. Now, if you don't have a tape measure, because you sort of need a tape measure for this, if you don't have a tape measure, let's just for now measure in feet, using your actual feet and measuring it in steps, basically. So if you want to say, I put my foot back to back, and this is how many of my feet are the length of my room, this is how many feet of the width of my room, then that would be totally fine. If you have, for example, tiles on your floor, you might actually be able to use the tiles on your floor, because sometimes tiles are 1 foot by 1 foot, which I mean, we don't usually use in the feet and yards, but we, in this case, I'll make an exception. Anyway, so that's sort of looking at perimeter, and we're going to explore this a little bit more tomorrow. Have a good morning.